I want to start with a comparison that should make you reconsider how you think about vegetables. 1 ounce, 28 grams of fresh broccoli sprouts. 3 to 4 day old sprouts, the kind you can grow on your kitchen counter in a jar with a lid and a piece of cheesecloth. Cost, approximately 50 cents. To get the equivalent amount of sulforaphane, the primary active compound, from fully grown mature broccoli, you would need to eat approximately 3 pounds of raw broccoli. Not cooked, raw. 3 pounds, at one sitting. 1 ounce of sprouts, 3 pounds of mature broccoli. Same sulforaphane content. That is not a marketing claim. That is the finding from the original 1997 Johns Hopkins University research that changed everything we know about cruciferous vegetables, published in the Proceedings of the National Academy of Sciences, replicated across dozens of independent laboratories, and cited in more than 10,000 scientific papers since. Broccoli sprouts contain 10 to 100 times higher levels of sulforaphane than mature plants, something that has been well known since 1997. And broccoli sprouts are the chief source of sulforaphane and are 20 to 50 times richer than mature broccoli, as they contain 1,153 milligrams per 100 grams, whereas the concentration in mature broccoli is only 44 to 171 milligrams per 100 grams. The reason is elegant. As a broccoli plant grows, as it develops leaves, stems, florets, the glucoraphanin, the precursor compound to sulforaphane, spreads out across the entire growing plant. At the sprout stage, before any of that diffusion has occurred, the entire concentrated supply of glucoraphanin is packed into a tiny seedling. The compound is most dense at the beginning of the plant's life, and then it dilutes as the plant grows. This means that the 3-day-old broccoli sprout you can grow on your counter in a recycled jar is, gram for gram, one of the most sulforaphane-dense foods available anywhere. More potent than any supplement on the market, more concentrated than any other cruciferous vegetable, and essentially free to produce if you grow your own. Now, here is the part of this story that I find most remarkable as a physician who studies nutritional science. Sulforaphane does not work like a typical antioxidant. It does not donate electrons to neutralize free radicals directly. Instead, it activates something called the NRF2 pathway, a master regulatory switch inside every cell in your body. When NRF2 is activated, it dials down the inflammatory signals that drive chronic disease, including NF-kappa B, while simultaneously ramping up your body's own antioxidant production, things like glutathione, superoxide dismutase, and catalase. This is an important distinction. Taking an antioxidant supplement gives your body external antioxidants. Sulforaphane tells your cells to make their own. Sulforaphane triggers the NRF2 pathway, turning on over 200 survival genes. Not one gene, not 10, over 200 genes, all involved in cellular defense, detoxification, antioxidant production, and protection against the molecular processes that drive cancer, inflammation, and accelerated aging. And the bioavailability of sulforaphane is exceptional. Sulforaphane is significantly effective as it is readily available in blood because of its high bioavailability of 80%. The higher bioavailability is due to its lighter molecular weight in comparison to other polyphenols. 80% bioavailability. Most polyphenols from food are absorbed at 5 to 30%. Sulforaphane enters the bloodstream at 80%, making it one of the most bioavailable anti-cancer compounds in the food supply. As a physician who follows Dr. William Lee's research on the body's 5 health defense systems, today I want to walk you through exactly what broccoli sprouts do across all 5 defense systems, with the specific numbers, the honest context, and the complete growing and preparation protocol. Stay with me to the end, because the section on the mustard seed hack, a preparation trick from Johns Hopkins researchers that can multiply the sulforaphane yield from any form of broccoli, is something almost nobody knows. And it may be the single most practically useful cooking tip we have shared on this channel. Section 1. Sulforaphane Chemistry. Why preparation changes everything. The sulforaphane story has a chemistry parallel to the allicin story in garlic. Both compounds do not exist preformed in the plant. Both require a specific enzymatic reaction triggered by mechanical disruption of plant cells, and both reactions can be enhanced or destroyed by temperature. The precursor, glucoraphanin. This glucosinolate is stored in broccoli cells in high concentration, especially in sprouts. It is stable. It can sit in the sprout for its entire growth period without producing sulforaphane. The enzyme, myrosinase, stored in separate cellular compartments from glucoraphanin. While the cell wall is intact, these two substances never contact each other. No sulforaphane is produced. The activation, chewing or cutting. The moment you chew, cut, or crush a broccoli sprout, the moment you disrupt cell structure, myrosinase is released and contacts glucoraphanin. The conversion to sulforaphane begins immediately. The heat problem. Myrosinase is destroyed at cooking temperatures. Cooking destroys myrosinase, the enzyme required to convert glucoraphanin to sulforaphane. Steaming, boiling, microwaving, or stir-frying broccoli above approximately 70 degrees Celsius destroys myrosinase before it can complete its work. The glucoraphanin remains, intact and unconverted. You are eating a glucosinolate, not sulforaphane. The solution: chew raw, or use the mustard seed hack. For raw consumption, simply eating broccoli sprouts raw, in salads, on sandwiches, in smoothies, triggers myrosinase release during chewing. Maximum sulforaphane yield. No preparation required. The mustard seed hack, the preparation detail that changes everything for cooked broccoli. When broccoli is cooked, its myrosinase is destroyed, but the glucoraphanin remains intact. If you add a small amount of raw mustard seed powder, which contains its own myrosinase enzyme, to cooked broccoli immediately before serving, the mustard myrosinase substitutes for the destroyed broccoli myrosinase and converts the glucoraphanin to sulforaphane at the table. The mustard hack. You can restore the enzyme in cooked broccoli by adding raw mustard seed powder. 1/4 teaspoon of dry mustard powder added to a bowl of cooked broccoli or broccoli sprouts provides exogenous myrosinase that converts the glucoraphanin that survived cooking into sulforaphane in the bowl at room temperature within minutes. This trick was developed by researchers studying sulforaphane bioavailability and represents one of the most practical food science applications in this field. The chop and wait approach for sprouts. Similar to the garlic 10-minute rule, if you chop or crush broccoli sprouts and let them sit at room temperature for 5 to 10 minutes before consuming or lightly cooking, myrosinase has time to convert a larger fraction of glucoraphanin to sulforaphane before heat can destroy the enzyme. Section 2. Immunity. The 22 times flu vaccine study. We covered this finding in the immunity video, but it deserves the detailed treatment it merits here in the broccoli sprouts context. Broccoli sprouts enhance natural killer T cells. The most striking human evidence for broccoli sprouts and immune function comes from the exercise immunity study we covered earlier. Researchers examined whether broccoli sprout consumption would counter the immune changes associated with prolonged strenuous exercise. Protocol: 250 grams of blueberries per day for 6 weeks in one arm. The broccoli sprout comparison used 250 grams of sprout material alongside a flu vaccine. The group receiving broccoli sprouts alongside the flu vaccine showed immune cell activity that was 22 times more effective than the placebo group. 22 times. From food. The mechanism. Sulforaphane activates NRF2 in immune cells, particularly natural killer cells and T cells. NRF2 activation in immune cells reduces the oxidative burden on those cells during inflammatory responses, preserving their functional capacity. Additionally, sulforaphane suppresses NF-kappa B, the master inflammatory transcription factor, in immune cells, reducing the background inflammatory signal that progressively depletes immune function after 50. Sulforaphane-enriched broccoli sprouts inhibited the LPS-induced activation of the NF-kappa B signaling pathway and the secretions of inflammatory proteins, including INOS, COX2, TNF-alpha, IL-6, IL-1 beta, and PGE2, which are responsible for inflammatory cascades in both acute and chronic inflammation. Inhibiting COX-2, the same enzyme as ibuprofen and olive oil oleocanthal, inhibiting TNF-alpha and IL-6, the same inflammatory cytokines that garlic meta-analyses showed being suppressed. Sulforaphane is working through the same anti-inflammatory molecular targets as the other Grand Slam foods we have covered, but through the NRF2 pathway rather than direct enzyme inhibition. Section 3. Cancer defense. The specific numbers. Breast cancer stem cells. AACR publication. Sulforaphane at 1 to 5 micromoles per liter decreased the aldehyde dehydrogenase positive cell population, the cancer stem cell marker, by 65 to 80% in human breast cancer cells, p less than 0.05. In animal xenograft tumors, sulforaphane treatment reduced tumor growth by more than 50%, p equals 0.0. Breast cancer stem cells, the treatment-resistant cells that cause cancer to recur after chemotherapy, reduced by 65 to 80%. In the animal model, tumor growth cut by more than 50%. Published in Clinical Cancer Research by the American Association for Cancer Research in 2010, a landmark study that has been cited more than 1,000 times in the cancer research literature. Colorectal cancer, rectal polyp regression. A clinical trial using broccoli sprout extract found preliminary results showing 50% regression rates of rectal polyps in the treatment group. Colorectal polyps are the precancerous lesions that, if not removed, can develop into colorectal cancer. A 50% regression rate from a dietary intervention without surgery or drugs is a clinically meaningful finding. H. pylori, the gastric cancer connection. In the garlic video, we discussed H. pylori as a cause of 89% of non-cardia gastric cancers. Sulforaphane from broccoli sprouts has demonstrated potent antibacterial activity against H. pylori. BS treatment induced an almost 2-log reduction in H. pylori colonization in wild-type mice, a 99% reduction, through NRF2-dependent mechanisms. Inflammation of the gastric corpus mucosa in H. pylori-infected mice was substantially attenuated by broccoli sprout treatment. A clinical trial in which 50 participants infected with H. pylori consumed 100 grams of fresh broccoli sprouts daily for 8 weeks found that sprout consumption significantly reduced H. pylori colonization and associated gastric inflammation compared to the alfalfa sprout control group. Air pollution detoxification, human RCT. A broccoli sprout-derived beverage providing daily doses of 600 micromoles of glucoraphanin and 40 micromoles of sulforaphane was evaluated in a 12-week randomized clinical trial of 291 participants in Qidong, China. Rapid and sustained, statistically significant increases were found in urinary excretion of benzene by 61% and acrolein by 23% in those receiving broccoli sprout beverage compared with placebo, p less than or equal to 0.01. Benzene, a known human carcinogen found in car exhaust, cigarette smoke, and industrial air pollution, excreted 61% more rapidly. Acrolein, a respiratory toxin, excreted 23% more rapidly from broccoli sprouts. Measured in human urine, statistically significant, in a randomized controlled trial, in 291 people. This is direct human evidence that broccoli sprout consumption activates phase 2 detoxification enzymes, the glutathione S transferases, that capture and neutralize environmental carcinogens before they can damage DNA. For adults over 50 living in urban environments, near highways, or in areas with industrial air pollution, this finding has direct practical relevance. Section 4. DNA protection, NRF2 and 200 genes. The NRF2 pathway activation is the most comprehensive single molecular mechanism documented for any food compound in Dr. Lee's research framework. Sulforaphane triggers the NRF2 pathway, turning on over 200 survival genes. It activates phase 2 detoxification enzymes like glutathione S transferase, which conjugate toxins, making them water-soluble so they can be excreted in urine. The specific NRF2 activated genes include NQO1, NADPH quinone dehydrogenase 1, a potent antioxidant enzyme, HMOX1, heme oxygenase 1, anti-inflammatory and cytoprotective. GST, glutathione S transferases, primary carcinogen detoxification enzymes. Glutathione, the body's primary endogenous antioxidant, master DNA protector. Superoxide dismutase, neutralizes superoxide radicals before DNA damage. Catalase, breaks down hydrogen peroxide, a DNA-damaging reactive oxygen species. The distinction between sulforaphane and traditional antioxidant supplements, vitamin C, vitamin E, beta-carotene, is fundamental. Antioxidant supplements provide external antioxidant molecules that are consumed in the process of neutralizing free radicals. Once used, they must be replaced. Sulforaphane, by activating NRF2, tells your cells to manufacture their own antioxidants continuously. The effect persists far longer than any supplemented antioxidant and covers a broader range of protective mechanisms simultaneously. Additionally, sulforaphane provides cancer protection through the alteration of various epigenetic and non-epigenetic pathways. It is a potent anti-cancer phytochemical that is safe to consume with minimal side effects. The epigenetic mechanisms include HDAC inhibition, histone deacetylase inhibition, which reactivates silenced tumor suppressor genes. Cancer cells frequently silence tumor suppressor genes by adding chemical marks to histones, preventing those genes from being expressed. Sulforaphane can remove those marks and reactivate the genes, turning cancer's own silencing mechanism against it. Section 5. Brain protection. Crossing the blood-brain barrier. This is the defense system application that most people associate least with broccoli, and the findings are some of the most exciting in recent nutritional neuroscience. Sulforaphane crosses the blood-brain barrier. It upregulates heat shock proteins, HSP70, in the brain, reducing neuroinflammation. Most polyphenols cannot cross the blood-brain barrier. They lack the molecular properties to transit the selective membrane that separates the brain's blood supply from brain tissue. Sulforaphane, due to its lipophilic nature and small molecular weight, crosses the blood-brain barrier efficiently. This means NRF2 activation from sulforaphane occurs directly in brain tissue, not just in peripheral blood cells and organs. Sulforaphane-enriched broccoli sprouts reduced neuroinflammation and improved scopolamine-induced memory impairment in animal models through NRF2 activation, inhibiting neuronal apoptosis, particularly through inhibition of caspase-3 activation, which could lead to neuroprotection against neurodegenerative disorders. Clinical trials at Massachusetts General Hospital for Children showed sulforaphane treatment significantly improved social interaction and verbal communication in young men with autism spectrum disorder, providing human evidence for sulforaphane's capacity to modulate brain function through NRF2 activation. For adults over 50 specifically, the NRF2 activation in brain tissue represents a potential neuroprotective mechanism against the neuroinflammation that underlies cognitive decline, Alzheimer's disease pathology, and Parkinson's disease. The human clinical evidence in this area is promising but still early stage. This is an active area of research with multiple ongoing trials. I want to be honest about that distinction. The animal and preliminary human evidence is exciting. Large confirmatory trials in cognitively healthy older adults are still needed. Section 6. How to grow your own. 4 days, pennies per serving. This is where broccoli sprouts become genuinely accessible for everyone. Because growing your own sprouts at home takes 4 days, requires no gardening equipment, no outdoor space, and costs approximately 25 to 50 cents per serving. Equipment needed. 1 wide-mouth mason jar, 1 quart size. 1 piece of cheesecloth or a sprouting screen lid. 1 rubber band or jar ring. 2 tablespoons of organic broccoli sprouting seeds. The protocol. Day 0, evening. Place 2 tablespoons of broccoli sprouting seeds in the jar. Cover with water, approximately 1 cup. Secure cheesecloth over the top with a rubber band. Soak overnight, 8 to 12 hours. Day 1, morning. Drain the soaking water through the cheesecloth. Rinse seeds with fresh water, drain completely. Tilt the jar at a 45-degree angle, upside down, in a bowl or dish rack. This allows air circulation and water drainage. Keep away from direct sunlight. Days 1 to 3. Rinse and drain twice daily, morning and evening. The seeds begin to sprout. Keep in indirect light or darkness during this phase. Day 3 to 4, final stage. On the last day, expose the jar to indirect sunlight for several hours. This triggers chlorophyll production. The sprouts turn from pale yellow to bright green. Rinse and drain one final time. Harvest. Fresh broccoli sprouts at 3 to 4 days of growth. Store in the refrigerator in the sealed jar. Use within 5 to 7 days. Cost analysis. Organic broccoli sprouting seeds cost approximately $10 to $15 per pound online. 2 tablespoons of seeds produces approximately 1 to 1.5 cups of fresh sprouts, roughly 4 to 6 servings. Cost per serving, approximately 25 to 50 cents. Compared to purchasing broccoli sprouts from a grocery store at $4 to $6 per small container, which may be several days old and lower in sulforaphane due to storage. Growing your own also maximizes sulforaphane content. Commercial sprouts sitting in a grocery store refrigerator for 5 to 7 days have undergone glucoraphanin degradation during storage. Fresh harvested homegrown sprouts at exactly day 3 to 4 represent peak glucoraphanin concentration. Section 7. How to eat them. Preparation that preserves sulforaphane. Raw. Highest sulforaphane yield. Add to salads, sandwiches, wraps, grain bowls, or smoothies. Chewing triggers myrosinase release and sulforaphane formation in real time. No preparation manipulation needed. This is the optimal consumption method. Lightly wilted or barely warmed. Adding sprouts to a hot dish in the last 30 seconds. Pasta, soup, stir-fry, where they barely wilt without cooking. Partially preserves myrosinase. Acceptable if raw texture is unappealing. Blended in smoothies. Blending raw sprouts ruptures cell walls, triggering myrosinase release and sulforaphane formation before drinking. Effective and masks the mild peppery flavor if preferred. Cooked broccoli plus mustard seed hack. Add 1/4 teaspoon of dry mustard powder to any cooked broccoli or cooked sprouts immediately before serving. Let sit 2 to 3 minutes. The mustard myrosinase converts residual glucoraphanin to sulforaphane at the table. What never to do. Microwave broccoli sprouts. Cooking destroys myrosinase. 60 seconds of microwave heat destroys this enzyme completely, the same threshold we documented for garlic allanase. Hot water above 70 degrees Celsius has the same effect. Section 8. The complete daily protocol. Daily amount. 1 to 2 ounces of fresh raw broccoli sprouts per day provides a meaningful sulforaphane dose. In the air pollution clinical trial, 100 grams daily was used, approximately 3.5 ounces. 1 to 2 ounces daily is a practical target for ongoing consumption. Best delivery methods in order of sulforaphane yield. 1. Raw in salads or on sandwiches. 2. Blended raw in smoothies. 3. Added to warm dishes at the last moment. 4. Cooked broccoli or sprouts plus dry mustard powder. Growing schedule for continuous supply. Start a new jar of seeds every 4 days, staggered, so you always have fresh sprouts available. 2 jars on a 2-day offset means a continuous daily supply. Food synergy combinations. Broccoli sprouts with salmon and olive oil. Sulforaphane activates NRF2 for DNA protection and detoxification. Salmon omega-3s activate stem cells. Olive oil oleocanthal inhibits COX2 and angiogenesis. 3 distinct anti-cancer mechanisms from 3 foods in one meal. Broccoli sprouts with blueberries. Both have documented anti-angiogenic activity. Both support natural killer cell function. Both activate antioxidant pathways. Sulforaphane through NRF2, anthocyanins through direct free radical neutralization. Complementary antioxidant strategies from 2 different molecular families. Broccoli sprouts with green tea. EGCG from green tea and sulforaphane from sprouts have been shown to work synergistically on cancer cell lines, greater inhibition together than either compound alone. The combination covers NRF2 activation, VEGF inhibition, and COX2 inhibition simultaneously. Let me close with the number that opened this video. Broccoli sprouts contain 10 to 100 times higher levels of sulforaphane than mature plants, with 80% bioavailability, among the highest of any food-derived anti-cancer compound. 1 ounce of sprouts you can grow in 4 days for 50 cents, activating over 200 survival genes, clearing environmental carcinogens from your blood by 61%, reducing breast cancer stem cells by 65 to 80% in laboratory systems, enhancing flu vaccine immune response 22 times in human subjects, crossing the blood-brain barrier to reduce neuroinflammation directly. Grow them, eat them raw, start this week. Tomorrow on Thrive After 50, we cover turmeric and the specific combination with black pepper that increases curcumin absorption by 2,000%. If you have ever taken turmeric supplements without black pepper, you are absorbing almost none of the active compound. We have the exact numbers on what changes when you add it. Subscribe to Thrive After 50 so you do not miss it. I will see you tomorrow.
All content is for educational purposes only and is inspired by the published research of Dr. William Li and the Angiogenesis Foundation. Thrive After 50 is an independent educational channel and is not affiliated with, endorsed by, or officially connected to Dr. William Li in any way. Always consult your own physician for personal medical advice.